I think we can start.
Maybe
Good morning.
we should start to be on time.
So good morning. My name is Dimitris Karpouzos. I am associate professor at Aristotle University. And as a member of the organizing committee, I would like to warmly welcome you for the second day of the Water Youth Congress. This online congress is co-organized by the UNESCO Center on Integrated and Multidisciplinary Water Resources Management, hosted by the Aristotle University in Greece, the UNESCO's Intergovernmental Hydrological Program, the youth delegates to the World Water Council, and the International Association for Hydro-Environment Engineering and Research. During this day, we will have the pleasure to attend interesting presentation by young scientists, as we did yesterday, and giving them the opportunity to engage in fruitful discussions with our mentors. The sessions of today refer to three topics: management of groundwater resources, the invisible water; resilience of societies and digital communication and cooperation; water-related disasters and climate change. Dr. Ouazar is with us today, and we will deliver a keynote presentation with title Water as a Good and a Risk within the context of climate change and COVID-19 to kick off this exciting second day of the Congress. So let me introduce Dr. Ouazar. Dr. Ouazar is a professor of computational civil engineering and water resources. He is a resident member of Hassan II Academy of Science and Technology. He is the national representative of the International Association of Hydrological Sciences, member of High Water and Climate Council, and founder of Adaptation Metrics and Techniques Cluster for Water, Agriculture and Cities. He is a former president of a university and former director of School of Engineering. He is a former member of Scientific Committee of COP22 and Scientific Board of the National Research Council of Morocco. And he has served also as a member of the Higher Council of Education, Training and Scientific Research and the Scientific Research Commission in Morocco. He is also a member of the Scientific Committee of Adaptation Agriculture Africa-Moroccan Initiative. He was African Scientific Research and Innovation Council Vice Chair since November 2021 and represents this council as a co-founder of the International Platform of Adaptation Metrics. He is also the Associate Editor and the Executive Director of Frontiers in Science and Engineering International Journal. So I would kindly ask Dr. Ouazar to take the floor.
Can you hear me?
Yes, perfectly.
Yes. Okay. Thank you. So I'm trying just to figure out. Thank you so much for this introduction. So the youth scientists and our future, dear colleagues and friends, I am really pleased to deliver this keynote speech with some main messages about water. And of course, when we talk about water, we talk about climate as a good and as a risk. The outline of my presentation will be dealing with the global context and the main challenges. And then I will talk about the vulnerabilities and consequences of climate change and all the impacts on water resources as a good as a risk. adaptation versus mitigations. And they will talk about some paradigms of international water resources, of integrated water resources management and nexus concept with some ideas of extension. Summarized with water issues, good and risk. And then the main technologies and modeling aspects related to this scarce resource, and finally conclude. Well, you know, the global context is not that good because of employment, economic growth and competitiveness, sustainability imperatives, so many mega societal problems related to food security, health, energy, education, infrastructures, and all these global flows of components of products, services, knowledge, and people. The mega projects in technology in a highly competitive world. We are also in a world of accelerating technological progress, technology-oriented and technology-dependent world. Globalization and of economy, though with the war and things, we are rethinking the way economies should become. New world or change and complexities is a real rule. The economy is a knowledge-based one. Climate change constants and sustainable development goals. And a recent COVID-19 pandemic that has shown the failure of many things all over the world. Well, the challenges, of course, are the ever-increasing water demand because of demography, climate change and the impacts, reduction and deterioration of available water resources, and there is the management of the common to be shared water resources. That means water as a good, floods, droughts, and other disasters. This is the water management as a risk. Of course, related to all of this is our capacity with the human capital and the education. And then the citizen himself or herself, the mindset. What are the rights of water given the constraints, the contextual constraints? And of course, we know that we have two types of water. We have the conventional waters and the non-conventional waters. And we have to do a lot already by optimizing the use of conventional waters. And we see how to develop the unconventional water that is becoming nowadays in many countries the real new water because there is nothing else. Well, there are some key climate figures to start with. We know that according to IPCC, that temperature is varying from 0.85 to 4 degrees by the year 2100. That means 0.2 to 0.4 degrees per decade. The snow, we have less and less snow, 25% in the north and 50% in the south. The sea level is rising from 0.3 to 2.5 meter in 2100. That means an average of 1.2 to 2.2 millimeters per year. And we have 5 times more frequent extreme storms. That is, of course, alarming. And Adding to this, if you can have a look to the global map of physical water scarcity all over the world, we see a lot of red. A lot of red, that means that scarcity is high. And it's an alarming sign for the development, because, you know, development, the water is a prerequisite to the development. If we see also some of the simulations, we see that the percentage of change in rainfall, in precipitations, either rain or snow, is really decreasing. Well, now the vulnerabilities and consequences of climate changes covers a lot of sectors: agriculture, forests, water, coastal systems, ecosystems, health, community, energy, all the commerce. And so we have to see what are the real implications of this climate change, taking into account that the main impacts are the increasing of temperature, as we have shown that already, changes in precipitation patterns, climate variability, high water variability. That means that we have to optimize the freshwater efficiency of energy production, electricity, and use systems. Of course, everything is depending on the water. And the high water cycle perturbations has induced a lot of things: heavy rains that are more and more frequent, extended drought periods, increase of frequency and intensity of floods, natural disasters causing migrations, high food costs, and therefore social troubles. Water is right, but we have to find it. I would like also to show a little parallel between adaptation and mitigation. You know, mitigation is a well-defined matrix, is a ton of carbon, of CO2 issued with these future emissions to be reduced and best, of course, avoid if possible. But for the adaptation, the difficulty of the definition, because it's plural, it's broad, and there is an absence of generalized metric because it's sector dependent. For mitigation, the impact of differentiated mitigation, because 1.5 degree worldwide correspond to 3 degrees in Africa and Middle East. For adaptation, there is a need to accelerate and standardize national adaptation plans. There is a need to establish a link with the Sustainable Development Goals, a need to bring out some integrated initiatives, a need to establish a typology for funding issues. You know that there is an agreement, an accord of the COP 21, the Paris Accord, that are putting emphasis on adaptation for the South especially. Sorry. And for the mitigation, even in the South, in the Africa and Middle East, there are many initiatives for renewable energies, and especially solar, to try to go towards mitigation. So adaptation is highly needed, and it is more difficult to achieve. Now, let's talk about the water usages. So this is something you know, but I want to put emphasis on this just to show that there are so many stakeholders because we have domestic use, industrial use, agricultural use, and of course the nature itself has some needs of water. And you know that the agriculture is taking a great part of the water. In developed countries, this is something around 30% to 50%. But in the south and in developing countries, the agriculture might take something between 80 to 90%. That's a lot. And the water consumption in average from the figures of UNICEF is something like 600 cubic meters per inhabitant. That means 137 liters per day. This includes individual water consumptions, what we call the direct consumption, and the indirect consumptions. But nowadays, in many countries in the south, they are really in a stress position, and it is going worse. Now, for the paradigms used for dealing with the management of water resources, I want to share with you some extended integrated water resources management paradigm. In fact, we are all living in a watershed. Oops. Excuse me. In a watershed, so we have, usually we are within a basin. We should call it, in fact, not a hydrological basin, but a hydrogeological basin, because this can include all the types of waters, surface water as well as groundwater, without talking about the unconventional water within what is happening inside. So we have the basin, we have the hydraulic infrastructures, that means all the reservoirs, the dams, and to collect and mobilize water. And we have the usages. And we have, of course, interaction. We are in a climate change context. We are in a new socio-economical and environmental context. And we have the management of all these things with all the constraints of and the possible conflicts, risk, criteria, alternatives, and we have interaction between the basin and the infrastructure stored through the inflows and the impacts. We have also interaction between the hydraulic infrastructures and usages, the distribution and the demand, the usage and the basin. We have the offer and what is returning. So this was really the first paradigm and one of the best paradigms for managing water. And of course, you can add another dimension of water. Is this what you can call this stochastic phenomenon? It's highly variable. And then we have the paradigm, the conventional paradigm. You know, maybe is this one. This is what I can call conventional nexus, because you have the main component are water, energy, food, and of course, there is an interrelation between all these things, and I developed the idea of extended nexus. Because if you go through energy, we can develop another sub-nexus I call it innovative energy sources, and that's what we are living because we have renewable energies. We are going toward optimization and reduction of energies and waste valorization. The second one, to the food, we are seeking at food security. Food security is highly dependent on water, of course, the water dynamics, depends on the soil and the fertilizers. Excuse me. And then, the last sub-nexus is, I call it well-being. Of course, we need water for the well-being, but it goes with, it doesn't go without hydric-related health problem. And of course, we have all the risks related to water, the pollution issues, and so on and so forth. And education plays an important role. So this extended nexus, this vision is important, and to be combined with the extended integrated water resources management vision. Oops. Well, I talked already about the water issues. Of course, when you talk about water, energy is also there, and they are closely related and interdependent. Population growth and climate change, along with development in land use, economic activities, industry, agriculture, tourism, nature, and urban environment, combined to cause negative impact on water resources and using high water variability in space and time. One river basin may be suffering extended drought, while neighboring river basins may be experiencing devastating floods. Of course, we have the scarcity. Short and long-term future availability is really uncertain. In fact, all water-related affairs are uncertain, as demonstrated by the drastic predictions of IPCC and the numerous climate change models. What are the water resources development requirement? If we look at water resources, water as a good, in fact, you know that we have the 17 SDGs, and SDG 6 is related to water. We need water for everybody, and sewage as well. So appropriate actions are highly required to ensure enough water availability to meet future societal and environmental needs, and is essential to reinforce COP agreement to reach the Sustainable Development Goals by the year 2030. And of course, to do that, adaptation is highly needed. In fact, in the past, we used to use water in a sustainable way, which is not the case right now. And we have seen that, in fact, we have the conventional waters, that means surface water and groundwater. There is a session on a full session about groundwaters. That is the invisible part, and we have the surface water. And there is already a lot to do with the conventional waters, because we have to optimize the use, and we have to use new paradigms to have economy in water and share the water, distribute it accordingly. And we have the need to go towards advanced water technologies like wastewater reuse, brackish, and seawater desalination, without talking about water harvesting, rainwater harvesting. That is also a good component to add to unconventional waters. And then we have the integrated water resources management and nexus paradigm, consisting in balancing different water resources goals while respecting integrity of ecosystems combination when suitable, of course. Now, just to talk about the logic we have, in fact, you all know that in water issues, we don't need some numerical models and simulators, but also sometimes we use also some data-driven models. So I just put a picture here to show you this integrated loop, integrating models, data analytics, artificial intelligence, and optimization. It's a lot. In fact, everything is occurring in a watershed. So we have a physical domain, maybe some boundary parameters. We have a database management system. As the information in water is mainly spatial, that means geographic information systems are there. As our data and parameters are not quite well known, we have recourse to remote sensing, to satellite images. Of course, the accuracy will depend on the resolution of the image, but hopefully a lot can be done using open data satellite images for many cases. And we have the models that require phenomenology, governing equations, some knowledge, some data science. And of course, we have to develop the models. We do advanced hybrid modeling. That means we go back and forth from some labs or experiments to the physics, and we do some numerical computations. We might have recourse to high performance computing, depending on the size of the problems. I hope I have still some minutes. Yes, we have recourse to the technologies, Internet of Objects, of Things, telemetry, embedded technologies, mobile web technology, the web technology, and so on and so forth. I think you all know, and this is what is really highly needed. It is highly needed because it can help in data observation, because you all know that for water, we don't have models, we have recursive models. That means if you have more data, we can add them and then we can develop a new model. Well, this is just an illustration of the complexity of a watershed. You see all the combination of the things I talked about. A lot of things. You have the ground truth, you have the data, the GIS, the remote sensing, you have the models, you have the demography, and so on and so forth. As time is running, I have to conclude with some key messages. Significant impact of climate change are projected, and the expected impact in the coming decades are largely preventable. Decisions having long-term effects are taken every day, and today's choice will shape tomorrow's vulnerabilities. Much time is needed to motivate and develop the capacity to adapt and implement changes. Proactive planning is often more effective and less costly than reactive planning. Proactive planning can offer benefits today. Vulnerability and resilience are determinant. Knowledge-based decision tools, metrics, and techniques are highly required. This is the IPAM initiative. I encourage you to visit the site adaptationmetrics.gov. Filling the data gaps, you know, especially in the South, we need data observatories. Robust analysis and projections are highly needed at relevant scales. Observations are needed to improve the predictions. Modeling is a back and forth from the modeling and the observations. Modeling of extreme events is becoming crucial. Relevant scenarios must be developed. Development of interoperable integrated platforms embodying the data, knowledge, modelings, and scenarios are highly needed. Thank you very much for your attention. Thank you, Professor.
Thank you very much for this interesting presentation. I can see one raised hand from Dariana Isabel. Can you please, Nikos, give the floor to Dariana if there is one short question, because we have to proceed to the next session.
Yes, I gave her this floor. Dariana?
Dariana? Do you have any questions? No. So I think we can continue. We can move on to the next session.